Hello and welcome to Maths with Jacob. This lesson will focus on indices and multiplication. In the previous video, we introduced the idea of index notation and how it could be used to represent the answers in a neat and efficient manner. Specifically, we saw that 3 times 3 is 3 squared, 10 times 10 times 10 equals 10 cubed, and this string of numbers here can be represented as 4 cubed times 5 squared. Very efficient way of representing it. We can extend this idea to show how it works when we use letters instead of numbers. A times A is A squared. So it's exactly the same here. 3 times 3 is 3 squared. A times A times A times A is A to the power of 4. Okay, so it's exactly the same idea. Now, how do we represent a squared multiplied by a to the fourth? We can do it as follows. A squared we write this way. A to the power of 4 we write this way. So altogether we have 6 a's together that are multiplied together. So it's a to the power of 6. The above calculation leads us to one of the most important rules in algebra when using index notation. And this is the rule. If you multiply two or more terms that have the same bases, keep the bases the same and add the indices. Okay, so that's what we've done. We're multiplying two terms here. The base here is A and the base is A. So we keep the base the same and we just add the indices. 2 plus 4 is 6. Let's see some examples on the next slide. The word indices is the plural of the word index. So indices is the plural, index is the singular. Another name for indices is powers. So in your mathematical career, as you go through your schooling, you'll be using indices and powers interchangeably. Okay, we've got 5 squared times 5 to the power of 4 is 5 to the power of 6. The base is 5, we add the indices. It's exactly the same for the letters. M and M give you the base. 3 plus 4 is 7. Keep the base the same. This one is slightly different. Here we have numbers in front of the letters. They're called coefficients, those numbers there. So you're allowed to multiply those together because they're just normal numbers. 6 fours are 24. Now we go to our rule. We've got y to the power of 3 by y to the power of 5. That gives you y to the power of 8. So that's the answer. Here we're allowed to multiply the initial numbers or the coefficients together. 2 3s are 6, 6 5s are 30. Here we have the powers or the indices are 3, 4 and 1. Okay, you can't see it, but it is a 1. And that gives you k to the power of 8. So that's the answer. Now we can have a string here with different letters. That's no problem. So let's see how we attack this one. E squared times e to the power of 3. We can group those together because the bases are the same. That gives you e to the power of 5. So that's that part. Over here, the bases are the same, so we can group those together. So that gives you h to the power of 9. So it's e to the power of 5, h to the power of 9, and they're multiplied together. Over here, it's very similar. We just look at, so you've got to group together the terms with the same base. There's the w and the w. 3 plus 4 is 7. There's the m and the m. 2 plus 6 is 8. So that's the answer. Over here, it's a longer string of terms, but the principles are the same. You look for the terms with the same base. That's the important thing. 3 4s are 12, so put the 12 there. H squared by h cubed is h to the power of 5. That's that term done. Now we look at that one and that one. 2 5s are 10. W to the power of 4 by w to the power of 7 is w to the power of 11. So it's 12h to the power of 5 by 10w to the power of 11. 12 10s are 120. H to the power of 5, w to the power of 11. Number 8, we have the like terms there. 3 2s are 6, so there'll be 6k to the power of 5. We have that one with that one. That will be 2 4s are 8, y to the power of 9. And we have that one and that one. 2 5s are 10, m to the power of 7. 6 8s are 48, so that gives us 480. And you keep the letters the same and the indices the same. And over here we have those two there. We haven't seen anything quite the same as this, but the principles are exactly the same. M to the 4th times m to the 7th is m to the 11th. K cubed times k squared is k to the 5th. Keep the bases the same and just add the indices. So this video has introduced us to a very, very important rule which shows us how to multiply terms together when we have bases and indices. And the important rule is when the bases are the same for two or more terms, keep the base the same in the answer and just add the indices.